All right, so here's the basic idea. First model of the atom
winds up being a
takes
ratio.
protons and neutrons, places them in the nucleus.
Have you guys heard about density
He
before?
developed the solar system model of the atom.
Okay.
So he's
Density
got electrons
is a measurement
in
of two measurements
concentric
combined
rings.
together.
Concentric
So
means
it's
that the rings
mass
are getting
combined
bigger
with
and bigger
volume,
as
and
you
it's a
go farther and
comparison
farther
of
out.
two. How much mass do you have per
Each
unit
of those
volume?
rings winds up holding a different number of electrons.
Sometimes we
They're
talk
different
about how
sizes.
tightly packed
The
an
first
object
ring can hold
is,
2 electrons.
how much stuff
The
it
second
has
ring
in
can
it
hold
per
8
unit volume.
electrons. The third ring can hold 8 electrons.
Units of density winds up being grams per
And
milliliter.
I've got a little ellipse there. It gets
make
a
a note
little
here.
bit more complicated as
Grams
we go
per milliliter
out to farther and farther
and
rings.
grams per
but I'm gonna
cubic
try and keep
centimeter
things simple for
are
right
the same
now. Is that
thing,
okay by you
because a
guys?
milliliter is a cubic centimeter.
Basically, what
Grams
this
per
model is going to help
cubic
us with
decimeter
is it's going to
is
help us to
different.
explain something called the octet rule.
You got the equation
octet
here,
rule
density
describes
equals
why atoms like to be reactive.
mass
It turns
over
out that the octet
volume.
rule states very simply that atoms wind
The
up
one
being
thing to
more
mention when
stable
you're talking about density,
if they have 8
the question is
valence
why is it important to
electrons.
talk about? Density actually determines whether
So the
things
reason why
are
we
going
want to be able to
float
draw Bohr
on top of
models
other things or
is
not.
we want to be
I
able
know
to
we say
determine
things
how many
like,
valence electrons are
the reason
in
why hot air balloons
a
float is that they're
atom
lighter than air.
visually.
Lighter implies that you're only measuring one thing. Weight. We're actually measuring two things. We're
One
measuring
thing to
the
point
density.
out here.
Things that are less dense float.
And this was a question on the
things that are
WebQuest
more dense.
you guys did the first
Okay,
day
so
of
the
this
whole reason
unit.
why hot air balloons rise is
There's a
because they're
difference
lighter than air.
between
It's
an
because they're
electron
less
that lives
dense
here in the first
than the
energy
cold air
level
that surrounds
and an
it.
electron that lives way out here in the
And that's something else that's
third
kind of interesting
energy
too. How
level.
often do you see hot air balloons in the summer?
Okay. The difference between those two electrons
Not
is that
much,
one
right?
of them has a
That's
lot
because
more
the air
energy.
is hot. So if you got a hot air balloon, there's not enough difference between
farther you
the
get
air
from the
inside the balloon
nucleus,
and the air that's
the more
outside the
energy they
balloon
have.
to get
So
enough
this
buoyancy,
is less
to get
energy.
enough lift. When you get to the autumn, you start seeing polar air.
E-N-E-R-G-Y. There we
So
go.
that means that the
So
hot
that's
air
less
inside
energy
the balloon
there.
is going to
And
be
this
hot enough
electron out
to
here
get
would
enough
have
buoyancy, to get
more
enough lift out of it.
energy.
Okay. As far as solving density problems, we can look at things visually.
What's holding these electrons
Sometimes we
into
get
the
a
atom?
microscopic view like this.
Right,
If each of these boxes has the same
nuclear force,
volume,
right?
which
You've
of
got
these
you've got the
which of these
protons
things
that have a nuclear force that are
is more
holding these
dense?
electrons in? So an electrostatic force, I think, is what we've
The
been
one on the
calling
right
it.
or the one on the left?
Which ones are more
The
likely
left
to
is more
pop
dense,
off?
right? The one on the
Which
right
ones are easier to get rid of?
is less dense.
The outer ones, right? And there's two reasons for that. Number one, they're farther apart from each other. You hold two magnets far apart from each
Can I
other,
go
how much
forward?
pull do you have?
Yeah. Okay.
Not a lot, right?
Here's where the
You hold
bulk of
them
things
closer
happen
together,
that get difficult.
like the
anyhow.
first energy level and
math
the
problems.
nucleus. Now they've got a lot of hold.
The density of
The
ethanol,
second
colorless
reason why
liquid that
those
is commonly
outer
known as grain
electrons, those
alcohol,
valence
is
electrons, are
0.798
easier
grams
to
per
pop off
milliliter. Calculate the
is
mass of
because they're
17.4
farther
milliliters of
from
liquid.
the.
Did you write down the
We
equation?
said they're farther from the nucleus. They have more energy.
All right.
More energy means
More or less, this is
they're
just
able
going to be a
fly
matter
off
of
easier.
doing some nice math.
Examples.
If we're the original equation
basically,
was
in order to do a Bohr model of the atom,
equals
you need to
mass
know
over volume,
what
right?
atom you're doing. So the
we
first
want to
atom I
find
want to
mass,
do here is
so we've got
neon.
to rearrange the equation. Let's see.
How many
if
electrons
I
should
get
neon have in
volume
total?
multiplied on both sides, then I can get
10.
rid of it on the
Where are we
right.
getting that 10 from?
Volume times density is
The atomic
mass
number on the
over-
periodic table, right? 10
I
electrons.
can read up there, isn't it?
Okay. How many protons does it have?
All right.
10.
So if they're asking me to calculate the
neon
mass,
has a mass of 20,
mass is going to
so
be volume.
how many
which
neutrons does that mean it
reads
has?
as 17.4.
10, 20
according
minus
to
10
the
is 10.
problem.
And then I've got to draw
Milliliters
these 10 electrons.
times,
Okay, here's the first energy level.
Density, which is
the funny thing about electrons, guys,
0.798
is that they're negatively charged, and they're going to
grams
try and space
per
themselves out
milliliter.
as far apart from each other as possible. Okay, so these two
those
electrons
things
are
look
going
like
to
they have
probably
sig
be
figs?
spinning on opposite sides of the nucleus if they can.
How many sig figs will we want in an answer here?
How many can I fit
seeing
in this
3.
first orbital?
All right.
2, right?
So-
So I can fit more in the next. I can fit how many in
Mass
the
comes
second?
out to be
8.
rounded
Okay,
to 3
so I'm going to
sig
go
figs,
ahead and I'm going to space these guys out.
1.39.
Let's see. I kind of
And then if I'm throwing units on this, I've got to actually kind of analyze what's going on.
Here.
Milliliters are canceling
I'll put one
milliliters, leaving
here,
me with only
3,
one set of
4,
units. Grams.
5.
That's a good
6,
thing because I was expecting a
7,
mass, which should be measured
8.
in.
Now I had 10
grams.
electrons to draw. Did I draw them all? Yeah. Okay.
I typed it in wrong.
Can I go on to oxygen?
So the decimal isn't supposed to be there. The decimal is supposed
How
to be
many
here because I
electrons
typed in
will an oxygen atom have in
0.798
total?
instead of
Nick?
0.798.
It'll have 8, right? Atomic number 8. That means it has
All right.
8 protons.
So this problem is
oxygen has a
fun,
mass of
according to Patrick
16.
here.
So how many
They
neutrons?
say we got a volume of 60 cubic inches.
And I've got to draw a total
which
of 8
appears to be
electrons. So I'm going to do the same
not
thing I did in the
a
last drawing.
set of units
Okay.
we can use.
2 electrons in the first energy level.
So I'm going to take that 60
and then I've got to
inches
draw.
cubed.
Ooh, how many more do I have to draw?
And
Only 6.
I'm
right?
going to convert
Okay, I'll
that
probably space these out
from
about
cubic
as
inches
evenly as I can.
to
also.
cubic, oops, not
I think I
inches,
can put one
to
here,
cubic centimeters.
2, 3,
Okay. Here's what I
4,
promised I'd show you guys
5.
yesterday.
and there's a
Remember,
sixth
we had
one.
to do this in 3 steps yesterday.
So if we're going to take a look at
inches
an
to
ion,
centimeters, inches to
lithium
centimeters, and
ion.
inches to
Ooh,
centimeters.
alkali metal people.
Here's a
What
quicker way to
charge
do
does
it.
lithium get?
1
All right.
cubic inch
So lithium
is
is a +1 charge
2.54
when it's an ion. Bless you.
cubic centimeters.
Lithium
put this in
is atomic
parentheses
number
just so it
3.
kinda
That
looks
means
like
it's
it's
got 3
sticking together.
protons. Its mass is almost 7, 6.94.
Okay, so if I take that
so how many
60
neutrons?
and I multiply it by,
4.
multiply it
Okay.
by 2.54 cubed.
Now here's where we have to
Isn't
think.
that the same thing as multiplying it by 2.54?
What does this say about the
3 times?
number of electrons?
Okay. So that should give me
One less
cubic
than normal,
centimeters.
right? So
Yeah, it looks like I only want
it
3
usually
sig
has 3,
here,
so I
I'm
get
going
to
to write
only
down
draw
900
2.
83.
Okay, so I'm going to write down 2 electrons here.
cubic centimeters.
And I'm just going to go ahead and draw
is
those
the
again.
volume.
They're going to be in the
of
first
this
energy level
rectangular metal
because they
bar.
always start in the first energy level and build out from there.
If we're going to calculate the mass,
So for the oxide
Mass
ion here,
is
guys,
still-
we're
Did we
going
just
to
calculate mass in the
oxide.
last one?
Oh, hey, we just did that,
Volume
right?
times
Oxygen has 8 protons and 8 neutrons.
so I should be able to take the
oxygen
volume
group.
of it, which is
What
983
is the charge of the oxide
centimeters
ion?
cubed. Multiply it by the density, which is 1.
Oh, come on, oxide group. Who did the oxygen
grams
group?
per centimeter cubed.
So we'll
And
continue
if you're
this
writing
drawing.
down the units, you notice right away that these
We got 2
cubic
electrons in the
centimeters and those
first.
cubic centimeters
And hey,
cancel.
this is going to be easy. There's 8
If you're not writing
in
down
the
the units, you
outermost
might have tossed in 60 inches
because I
cubed
still have 8 left to go.
in here and not
1, 2,
notice that the
3,
units
4,
don't cancel and got
5.
the wrong answer.
6, 7. I didn't do such a great
Mass
job
to
about
3
spacing
sig
out.
figs
We
should
got 8
be,
in that outermost energy
let's see,
level.
1,415,
Ooh, you know what I should tell you guys?
which I'm going to round to
Here's the thing.
1,420.
If you gain electrons, I did this wrong.
The units on this is
It's
grams,
got 2 extra
right?
electrons. The way
Which
we
we have to
usually
convert to
symbolize in a Bohr
kilograms.
model, that they're different, that they
many
came from
places do I have to
someplace
move the decimal for
else,
that?
they're not actually from the atom, the neutral atom,
Yeah.
because we put X's on
It
them.
says kilograms here, right?
Where could
How many places do we need to
oxygen,
move the decimal?
the
You guys
oxide
know?
ion have gotten these
3,
extra
right?
2 electrons
So
from?
I'm just going to say that this is the same thing as
Right.
1.4.
Our exceptions to the octet rule, I'm going to do the exception that's on the right-hand
kilograms.
side first.
Do I want the
Helium?
0?
Has 2 valence electrons,
Yes
right?
or no?
I'm sorry, helium has 2 electrons in total. So when I draw it, helium has 2 valence electrons. The octet rule states that atoms are going to be stable if they have 8 valence electrons. There's a few exceptions. This is one of them. It's going to be stable because its outermost shell is actually full. Can we put any more electrons in there? No. Okay, so it is going to be full. Hydrogen ion. Ooh, what's the hydrogen ion called? Actually, what do I write down for the symbol for hydrogen ion? It's H. Is it positive or negative? Uh-oh, I heard negative and I heard positive. It's both, right? It could be positive or it could be negative. Hydrogen positive, what should it look like? How many what does that mean about its electrons? It lost an electron, right? So what does a hydrogen ion look like? It's got 1 proton and no neutrons. This right now is a hydrogen positive ion. Okay, a hydrogen cation. If I want to do a hydrogen anion, on the other hand, what does that mean? It's got 2 electrons in total. It's gained an extra one, right? So a hydrogen anion is going to look like that. Is that going to be stable? Hydrogen anion will be stable because it's got 2 valence electrons. Okay. Let me go back real quick. Will the oxide ion be stable? Count up those valence electrons. How many does it have? 6 circles and 2 X's. That makes a total of 8. Will it be stable? Yeah, that'll be stable. Oxygen atoms are not stable. How about that lithium ion? Will it be stable? Its outer shell is full, so it'll be stable. Okay.